Well, as we have discussed earlier about the rigid body, now we have to connect rigid body with the torque. In all the rigid bodies, as I have explained earlier, they are made up of plenty of particles, nearly 10 to the power 20 per gram of the material, and all particles are arranged in three-dimensional repeated pattern. The axes are called the lattices, and the points on which the atoms are arranged or the particles are arranged are known as the lattice points. Moreover, the distance between every two particles or every two atoms in the whole of the rigid body is fixed, and that is called lattice parameter, nearly 10 to the power minus 10 meters, or about 1 angstrom unit. Now, when the whole body is rotating about an axis, the particles also rotate about their original axis. Now we have to relate torque with this axis of rotation or with the rigid body or the rotation. Well, torque is basically the product of force and perpendicular distance from the axis. So we take into consideration the vector as force and perpendicular distance from the axis. We multiply the two numbers and that gives the value of torque. Well, torque is also known as sometimes the moment of couple. So F into R, that gives the value of torque. So the unit will be Newton meter or it will be joule. So now the main concept is that turning effect of force about the axis of rotation is called the moment of force or the torque. Due to the force measured as the product of the magnitude of force and the perpendicular distance, as I have just now explained, between the line of action of the force and the axis of rotation. Moreover, when we use this term torque, it is widely used in most of the practical cases. So we find now that torque is force into perpendicular distance from the axis of rotation. Sometimes when we use it in electrostatics, we have to use it for finding torque in terms of electric field. In magnetism, we find torque in terms of magnetic field. And here it is in mechanics we are finding. So simply it is a mechanical force and the perpendicular distance from the axis of rotation. The SI unit of torque or the moment of couple is Newton meter, and Newton meter stands for joule. So the unit of work or the torque is the same. Dimensional formula of the torque is same as that of work or energy. Therefore, the dimensional formula is mL2T minus 2. Moreover, we can remember that torque is basically the work done in rotating a body about the axis, or it produces the turning effect. So the turning effect of force is basically known as the torque. Now the physical meaning of torque we have to go through it. So when we use the term physical meaning of torque, we are referring to the relation between the rotation and the radius of rotation and the perpendicular distance. So when we multiply small angular displacement, it gives the work done in rotational motion. The small work done is generally represented by dW, and when we integrate dW, it will become W, and that is the total work done for rotation. The quantity corresponds to force in linear motion, which when multiplied by small linear displacement gives the work done in linear motion. So linear motion means that is in straight line, and rotational motion means that is body moving about its own axis. The equation of torque in the vector form is generally given as the vector torque is equal to the cross product of radius and that is force. And the line of action of the force makes an angle with x axis. So that is the line of action of force makes an angle with x-axis. Now, if we assume that phi is the angle made by the line of action of the force, then the positive vector OP is given by vector R. That is the position vector. It will be more clear in the figure. So let phi be the angle made by the line of action of the force, and the positive vector OP is equal to position vector R. Now, if we will go through with the coming diagram, we will find that in the coming diagram, the summation of or the total of theta and phi, that gives the value of alpha, and the phi will be taken as alpha minus theta, and torque will be taken as, that is, in the scalar form, it should be R multiplied by F sine phi, or we can take, that is, F sine phi, that is the component, and R is the radius vector. This is expression for torque in the polar coordinates from O, drawn on the line of action of the force. Now, we have to consider for all these estimations the coming figure. So, consider the coming figure and just tally all these statements in triangle OPN sine phi. When we use the term sine of the angle, that is perpendicular over hypotenuse. So, in the given figure, phi means that is the angle between the two lines of a right angle triangle. Then side just in front of a perpendicular line or side in front of angle is called perpendicular. The longest side is called the hypotenuse, and the remaining side is called the base. Using that fact, we can say that in triangle OPN, sine phi must be ON over OP, and OP is equal to R according to the figure. So ON over R. So we can get the value of ON, that is R sine phi. We have torque as R into F sine phi, and F sine phi, that is R sine phi, will be replaced by ON. Therefore, torque can be estimated by function F into ON. Therefore, the torque due to the force is the product of force and perpendicular distance of the line of action of the force from the axis of rotation. Now, whatever earlier context we have gone through with, this is the figure to explain that particular context. That is, we are finding that ONP is a right angle triangle. Phi is the angle between the hypotenuse and the normal line. Therefore, the side just in front of phi will be perpendicular. So ON is behaving like a perpendicular, and NP line is behaving like a base, and OP line is behaving like a hypotenuse. The coordinates of point P are X and Y, and the another angle made in the dotted line from P and the dark line, that is phi. So two angles are vertical opposite angles, and R is the radius vector. So line of action of the force is indicated by a strong line where we have marked F vector. From the above expression, we can make certain important conclusions. R is maximum, torque due to force is maximum. So our conclusion is that R is maximum, torque due to force is also maximum, that is, torque is proportional to R. For example, we can open or close the door easily by applying the force near the edge of the door, and to unscrew a nut fitted tightly, we need a wrench with a long arm. Now, before proceeding further, Archimedes stated in 326 BC that if you give me a lever long enough and a point where the lever will touch the earth, I will apply a simple force and the earth will be turned. It means lever arm must be very long so that we can apply less force. The whole earth can be turned according to Archimedes if the lever length will be significantly large. Therefore, we will find here to unscrew a nut fitted tightly, we need a wrench with a long arm. Now, as shown in the figure, that the wrench is not hold right from the nearest point of the curves, rather it has been hold from a long distance. So if the lever arm is long, the force applied will be less. Now another thing, when the length of the arm is long, the force required to produce a given turning effect will be very small. This principle of lever arm is used in lifting heavy weights. So heavy weights can be lifted by using a long lever arm, and a point will be adjusted to the very heavy load. And lever always moves about a fulcrum. So lever is a rigid bar turning about a fixed point, and that fixed point is called fulcrum. So this principle of lever arm is used in lifting heavy weights. Now the third thing is torque will be maximum when sine phi will be maximum, that is 1. So phi must be 90 degrees because sine 90 will be 1. When force is applied in a direction perpendicular to R, it is easy to open or close the door by applying force perpendicular to the edge of door. That is, in all these concepts, what we are finding, that lever arm must be large. So lever is a rigid bar turning about a fixed point called fulcrum. Larger the length of the lever arm, very small force is to be applied to lift the heavy loads. Now, the fourth point is that if phi is 0 or 180 degrees, and we take the value of sine phi, that is sine 0 or sine 80, that will become 0. So, torque is equal to R sine phi or Rf sine phi, and if phi is 180 or 0, the net value of torque will become 0. Door cannot be closed by applying the force parallel to the door.